On this video, we will talk about model flexibility, which means how do you make it easier for yourself to make changes in your model when there are changes in the requirements. So let's get started. So let's start this by using this example from a contest we created a week ago, where the idea was to have an initial amount of bulk in a particular area and have bulldozers come to the area and take the bulk into a different area. Quite a simple model, but it was possible to increase in complexity as you made it more flexible. So let's see possible solutions for this. Okay, so let's see what the winner of this contest did. There are two parameters that are important that you want to see. First is the bulk volume, which is how much bulk there is in the initial location that needs to be moved to the second location, and the dozer capacity, which is how much can a bulldozer carry from that bulk, and that's the maximum. So he defined all these two things in main, and to define how many batches he needs, he linked the bulk volume with the dozer capacity. So in bulk source, the amount of batches generated depended on the dozer capacity, which is completely fine because the requirements were explicit to say that the capacity of each bulldozer was fixed to a particular number. So this is completely fine. But now the requirements changed. Now the client says, or your boss, that the bulldozer capacity is not actually 3. It's uniform between 2 and 4. Now, the first problem is that we defined the capacity in main. And one first lesson to learn is that each parameter of any agent or any characteristic of an agent needs to be defined always in the agent itself, not somewhere else. So this is the first lesson to take from this. Now we want to change this, but since each bulldozer now has a different capacity, we need to change this. We're forced to change this to the bulldozer agent. And if we compile it, we see a few errors that we need to correct. Can we correct them or not? The agent volume, which is the volume of the batch, is equal to the dozer capacity. But now the dozer capacity is not fixed. And in the source, we have no idea what bulldozer is going to take this batch. So this is impossible. We need to restructure everything, actually. So another problem that occurs here is that for this solution, the volume and the capacity, which are independent things, are linked together. We should never link things together. We should always make everything independent in its definition. So these are the two lessons that we want to learn from this. Now, let's see my solution. Okay, on this solution, I have the request defined in kilograms in here as a parameter. So it can be any number, it doesn't matter. In main, I generate a bulk request that is equal to that parameter. So I use the fluid source, but the fluid source amount is this. So I have an initial fluid source with all the bulk that I need to transport. So in main, I generate a bulk request, but only one, which has all the fluid or bulk that I need to transport. And I generate it here. Now, since it's only one with all that amount, what do I do in the move by transporter? But first, let's see that in the capacity of the bulldozer is defined in the bulldozer agent. This allows me to make changes very easily. It doesn't matter if I put anything here at 200, which is maybe the requirement, or a distribution, it doesn't matter. In main, when I select my transporter, what do? I calculate based on the bulldozer capacity how much can I transport from that bulk, and I will generate a new request after that based on the remaining of bulk that I need to transport. So I will generate the request, I will seize the transporter, and after that, if there's any amount remaining that needs to be transported, I generate a new request. So I will generate requests as there is bulk to transport based on the individual capacities of the transporters. And really, I can only do that if my characteristics are defined in the agent itself. And now, how do I link the batch with the bulldozer? I do it through a request link here. So I link the request with the bulldozer. And I don't make them dependent from each other. They're just linked. So that also allows me to be more flexible, and I can change the characteristics of the batches or the characteristics of the bulldozers way more easily if I make them independent from each other. Okay, now let's see this other model, which has a warehouse that produces something and then moves that something with a vehicle to a particular store. We have all this logic that belongs to the warehouse. So this is the vehicles that belong to the warehouse are flowing here. Also, the products are flowing here and picked up by the vehicle and transported somewhere to the route. The route is here. From warehouse, it moves to store, and then you have an exit block that transports that vehicle to the store. And in the store, you have your own little flow here to unload the products. Now, it's very important to notice here that each flowchart is defined in the agent in which things are flowing. This is very important. In order to make your models more flexible, you should always define things in the agents in which they belong. Here in main, the only thing that happens is the movements in the map, because the map is in main. This is important. Now, I have here defined certain parameters, and this is a mistake. As we talked before, you have truck product capacity, truck average speed, truck loading time, truck unloading time. Where should these parameters be? Should they be in main? Of course not. They can be, my model will work, but with changes in requirements, it's going to be more difficult to make changes in the model. So these four things should be defined in the truck and not in main. So even though there are many other ways in which you can make your models more flexible, you need to remember this. Lesson 1, always put the characteristics of your agent inside the agent. 2, make your agents independent in their creation and their behavior. And 3, generate the flowcharts inside the agents in which the things flow. And these 3 tips will already help you making your models more flexible.